Distance measures are fundamental components of machine learning and statistical modeling. Among the most popular metrics used to measure the distance between points or vectors in Euclidean spaces are Euclidean, Manhattan, Minkowski, and Chebyshev. All four of these measures are important when it comes to clustering, where they are used to calculate the proximity between a given point and the centers of clusters. We'll discuss the differences between these distance measures, their strengths and weaknesses, and what type of problems they best apply to. The Euclidean distance is the most commonly used distance measure. It takes the sum of the squared differences between all pairs of coordinates, then takes the square root of the result. This distance measure is optimal when distances between points decay at a constant rate. The Euclidean distance is ideal for applications that rely on the Cartesian plane, such as graphics, robotics, and geospatial navigation. The Manhattan or city block distance between 2 points is calculated by adding the absolute differences between all pairs of coordinates. It is named after the way one would measure distances between streets in a city grid. Unlike Euclidean distance, Manhattan distance does not consider angles or orientation. It works best where coordinates can be added or subtracted but not rotated, such as in image processing or linear programming. The Minkowski distance is a generalization of the Euclidean and Manhattan distance measures. It is designed to allow more flexibility, as it can be adjusted according to different criteria, such as the size of the underlying space or the application. Depending on the values of its two parameters, Minkowski distance can behave like either the Euclidean or the Manhattan distance. The last metric we are going to discuss is Chebyshev distance. It is the most forgiving of all four distance measures, as its calculation only considers the maximum amount of difference between any two coordinates. As such, it works best where measured connections are completely orthogonal and equal in importance. Overall, each of the four distance measures discussed above are important tools in a range of machine learning and statistical applications. The Euclidean distance is the most versatile for measuring distances in Cartesian planes, and Manhattan distance is effective for problems that involve vectors that cannot be rotated. Minkowski distance allows for greater flexibility, and Chebyshev distance is well suited for orthogonal equal problems such as checkerboards.